And there we are. So I want to take care of some of the house cleaning stuff first. Does anybody have any opens? Hey, with no opens, I did want to make mention of the fact that the soft freeze for EDK2 stable tech 2023-05 occurs next Monday on the 8th, and the hard freeze will occur on the 12th. Some information from the stewards update. Michael Kinney wasn't able to be here this morning, so I have the notes that I took yesterday from the stewards meeting. I presented about the GitHub security advisory process and what that looks like moving forward, and got the go ahead from the stewards to go ahead and move forward to move all of our InfoSec security issues to GitHub security advisories exclusively. So that will coincide really well with the 2023-05 stable tag release. And from this point forward, instead of using Bugzilla, we'll be using GitHub security advisories. There was some open discussion about the policy regarding fixes going in during soft freeze, after hard freeze, and the consensus was that it was worth delaying for critical and high CVEs, and that the policy was that if we're only in the soft freeze, then it goes in. But if it's during the hard freeze, then it would be considered on a case-by-case basis with inputs from the stewards and also from the InfoSec team. And in the event that that does happen, it may actually extend the release date. There was some discussion about device tree and possibly adding a conversion lib for the device tree lib. Some additional discussion about OpenSSL 1.1.1 end of life, which is September. They are working on getting OpenSSL into main, OpenSSL 3.0. The size impact is really large, and they're providing OpenSSL 3.0 for immediate consumption as a separate repo. For anyone who wants to get started with it. And during this process, there are changes that are being looked at to be upstreamed to reduce the size impact. And then the last thing that was discussed during the stewards meeting was the Tianocore docs contributors agreement. They're looking at some different agreements in order to make it a little bit more permissive. And with that, that takes care of all of the housekeeping items. I want to take and turn this over to Lynn Tipton, who's going to present about HBFA fuzzing and CI.
Thank you, Mickey, and thank you everyone for the opportunity to talk to you all today. One moment, working on bringing the slides up. And can everyone see that okay?
Yes.
Excellent, thank you. Thank you. All right, first, my name is Lynn Tipton, and I'm a security researcher in the Security, Privacy, and Mitigation group at Intel. And first, I wanted to point out this work is not solely my work. This is based upon input and work and help from a number of folks at Intel, including Mickey, Brian Delgado, Eric Porg, Antonio Gomez Iglesias, Lelia Barlow, and others in our teams, including Mathieu Tarral, who'll be speaking in the presentation immediately following this to detail some of his efforts, parallel efforts working with kAFL. For this presentation, I'll be talking about what we've been doing to enhance the host-based firmware analysis tool in terms of building containers, as well as some of the enhancements that we're trying to add in there to make things, add some additional capabilities. So for this talk, I'll just briefly dive into, kind of the why of fuzz testing for UEFI, Then we'll touch on, what is HBFA? Where is it? What state is it in? And then we'll go into some of our initial motivations for how we started this effort in building containers and enhancements to HBFA. Then we'll talk about, following that, we'll talk on our current efforts, where we're at right now, and where we're trying to go. We'll step through a brief workflow example of, what a workflow would look like automating a container in a fuzzing session. And then we'll last conclude with some of the future ideas and direction where we think this could go. And very much looking forward to any ideas from the community and suggestions. And, our hopes here are to upstream as much of this out as we can to help the community. So first, the why of fuzzing. So we consider fuzzing is a part of a suite of methods that should be used to enhance security. Included on this slide are several quotes and references to UEFI forum panels and presentations. And, they say the same thing, you should have a suite of different validation tools. One particular quote or question I liked that was at one of the panels, paraphrasing was, pick one, unit testing or fuzz testing. And I love the shortness and directness of the responses. Our opinion is that you don't pick just one testing method. So really our goal here and what we're really wanting to do is, one, internally at Intel, and then of course is externally, we want to reduce the friction, reduce the challenges for development teams to be doing these sort of validations and testings. And, the goal here is to augment, enhance HBFA and get it to where it can be in more hands and doing more fuzzing cycles. So the host-based firmware analyzer was originally contributed to the EDK community back in 2019 by Intel, and it currently resides as a branch in the EDK2 staging repository. And largely since 2019, there wasn't a lot of activity. Notably, there was an author that had brought in support for AFL Turbo. But that's more or less where things were. As you can see on the right side of the slide, I've got a reference and a picture of the white paper that came out about that time of the release. And that'll give you a good idea, kind of the high level, what it is and what's there and what's available. Really, this is a tool that's focused at fuzzing UEFI drivers and platform initialization drivers. Some of the interfaces and things that are built are mocked. Basically, your code is being brought into a binary on the user side of the operating system where your fuzzing session is occurring. So this makes it very convenient for one running in a container, also for a lot of developers. It's really best suited towards if you have unit testing to give you the ability to quickly wrap those and make those into fuzzing test cases and others. So it does help in that it enables integration of the original release has AFL, libfuzzer, an older version of Peach Fuzzer, and a simple WX widgets based GUI. And it has additional support for doing fault injection. CLI is there for helping you, generate a path to create a particular seed if you're wanting for your fuzzing session, as well as GCOF based with LCOF tool code coverage reporting. And one really nice thing the authors include originally is a pretty large suite of fuzzing test cases. So our motivation started internally at Intel because we want to get and support as much fuzzing as early in the process with as many teams as possible. And the first thing when we started picking this up and looking how can we help teams was that a lot of the installation for HBFA is very manual. It's really originally it was really geared towards, a user desktop environment and having the GUI and running the tools. And what we wanted to do was get this, to build a container for it, to be able to bring it into our CI/CD process. So that was the initial motivation. As we're doing this, we're like, we want to upstream this and do as much as we can to get this out to the community and get input. So again, yeah, a lot of the initial setup is very manual. You're going to different text files that they have as readmes, and you're setting up every tool and setting up your environment. Again, the goal here is to automate that. While we're doing that, we realized there were some additional updates that we can add to HBFA, including enabling additional sanitizers and giving some additional options for code coverage. And again, yeah, we wanted to add some additional features and build the space where we can start adding more features into HBFA. Our initial focus notably was not on the GUI. We haven't touched that yet. It's WX widgets based. Again, we have some different ideas we'll get to at the towards the end of the presentation with the future ideas. So where are we at right now? So our initial effort, we looked at Tianocore's containers, and we wanted to base off of that container because we know that Tianocore is using that in their testing and builds. And we focused initially on the Fedora 35 image. And basically, at present, what we're doing is we have a dynamic tool that will generate our Docker file, and it'll apply Git patches and insert the build targets into that Docker file. And basically from there, one builds out the entire Docker container environment. It's going to install HBFA, deal with all the environmental setup. Again, a lot of the things we did were things to make it convenient for a CI/CD environment and running commands from CLI, so such that things could be automated and you could quickly kick off your fuzzing session, and as well as generate reports and collect information. We were able to bring in and update to newer versions of Clang and libfuzzer, as well as we have a build recipe for Peach community, newer Peach community install. And yeah, again, very importantly, we're able to bring in the addition of MSON as well as a number of the subparts of UBSON for your fuzzing sessions with libfuzzer. And in addition to that, in terms of code coverage, the original was focused on GCOV. We were able to bring in profraw and leverage the LLVM and LLVM tool to generate output there as well. So you can get kind of coverage reports based on both. As well as, again, some of the ones that we're developing right now and working with are things to help with managing, pushing your corpus on and off the image, as well as a dynamic GDB script generator. So if you have crashes during your fuzzing session, then you can have this dynamically generated GDB script to rethrow your crash cases and collect crash state, backtrace, and register state, and that sort of thing. Right now, looking at the latest EDK2 build, we have 18 out of the 25 original fuzz testing harnesses building. We've reached out and been interacting with the original authors of HBFA at Intel, and we've passed along a lot of that information and had good feedback and inputs from them. And that's definitely informing what we're doing right now, trying to get stuff upstreamed. And importantly, we're definitely working on documentation as we go along, to support internal efforts. And we hope to get this filtered out to the appropriate parts and pieces to help people to be able to quickly get up to speed and use the tools. Again, right now, what we're working toward most immediately to release is basically a patch that would be against the Tianocore containers for the Fedora 35 image. And basically, that's the build recipe for HBFA, with the target for HBFA focused on the original AFL and libfuzzer, as well as an additional build target that will build in the Peach Community Edition. And we're also working on upstreaming a patch right now that would go to HBFA, and that would add in some of these additional capabilities of leveraging the other sanitizers and the LLVM coverage tool. So what does a kind of a workflow look like here? And again, here, this is representative of what we have right now internally. We've been working with Docker Compose on some large fuzzing internally. Outside of that, what's shown in this and the next slide will be some Git actions, and that hopefully will be something we can upstream as things come out, get patched. We'll have to adjust the recipe a little bit, but hopefully that can help people with their automation needs. So right now internally, our workflow looks like this. We have a dynamic Python script to dynamically generate the Docker file. Again, we have submodules in our repo for the Tianocore containers repo and the HBFA off of staging. And this tool will dynamically adjust depending on what build target we want for those repositories, as well as pull that in and dynamically generate the Docker file for building. We have some additional features and customizations where it'll let us put in additional settings for our internal proxy and all those kinds of things. Right now, as the tool sits, things will change as things get upstreamed, but something like this would be definitely useful to get out later to help folks depending on what it looks like, and that would let people incorporate some additional features into what's being done. So once you run this tool, You'll generate your specific Docker file with your build targets. And then the process from there is really straightforward, just standard Docker stuff. You're going to basically invoke building the Docker container image. And as it's doing that internally in the image, it's pulling EDK2, building everything there, making sure everything works, pulling in newer installing AFL as well as Clang and LLVM and any other packages and dependencies. And it also push in the patched version as it sits now of HBFA. Eventually, most of that or all that will hopefully be upstream, so then it will just be able to pull that directly. Then in terms of running the Docker container, that is pretty standard. You'll invoke it normally. One note is you need to invoke it with permissions just because of some of the settings needed for AFL. And as you can see in the bottom right, there's a little bit of a layout. There'll be a workspace directory, and a lot of the fuzzing harnesses will be to the build directory. But as you can see, we include a copy of the user documentation and some other parts and pieces. So once the image is built and the container is running, then internally we leverage a Git runner, and we have some of the additional helper scripts and tools on there that help move in our corpus for a fuzz test. Then it will generate first it'll initially build the entire image, launch the container, move the corpus in, run the fuzz testing case for a given duration. Then it's going to run all of the coverage generation data based upon anything in the queue from AFL or anything that's been produced from code paths from the fuzzer, and generate a picture and HTML report of the coverage. Then following that, if there were crashes detected, it will go through and run our dynamic GDB scripts and pull state for that, and then basically bundle everything up so that we can pull it off of the system. So direction, future ideas. So right now internally at Intel, we're working with groups, and we're trying to do a few pilot projects to help them with, look for corner cases and identify issues and problems and improve the toolage and hopefully inform, improve, and mature what we're doing, and then bring that back up to the community. Again, in the following talk, Mathieu will be talking about some of his efforts with kAFL. So there are additional efforts ongoing with various tools here, kind of the same vision of building a suite of different things to help different fuzzing needs for UEFI. And again, here noting the upstream to external community. Right now, what we're working on getting through the release process would be 2 patches, one against Tianocore containers for the build recipes, and then a second for HBFA for some of those adjustments and enhancements. Future, where we want to go, what we're thinking, and this is definitely somewhere I'd love to hear back from the community, any ideas and needs and issues. So in terms of Docker file generation, one, optimizing our container size, removing unnecessary dependencies, that kind of thing, maybe making it more granular. Other things would be Tianocore Containers has container images for Ubuntu-based distributions, so adding support for that. And then also for EDK2, when things are being built and it's pulling EDK2 into the container, giving the granularity to let someone select the specific EDK2 release they want to test against. And then additional things, adding support for AFL++. A very important one that's on our timeline to do here soon is developing this into a container in a workflow for OSS Fuzz and Cluster Fuzz. The goal here is obviously if we can get it into OSS Fuzz, that would be great for the external community to get a lot of continued fuzzing cycles that the community could operate and contribute to. Outside of that, the additional things of collecting the reports and results, doing further work on crash triage reporting, collecting the crash state, those sorts of things to help automate deduplication of crashes to help lessen the noise in the triage process, as well as anything else we can come up with to help with corpus handling and corpus minimalization. And then the kind of one big idea is for all of this, managing the fuzz session would be nice, knowing your results, what fuzz actions are happening. So if there could be a web dashboard for that, collecting the reports and results, keeping track of that. And again, this may not be a separate tool or thing developed. It may be that, for example, with like Cluster Fuzz, we may be able to just integrate into what they're doing and have that managed. So just some ideas for future tasking and improvements. And I believe that's all I have for the moment. If people are willing, we could hold for questions and comments until after Matthew's, and we can just take them all together and save some time for the next couple speakers. Likewise, anyone watching this video later, please feel free to reach out to me at earl.lynn.tipton@intel.com. Definitely looking forward to any ideas and suggestions. Thank you.
Thanks, Earl. I really appreciate it.
Thank you all.
So next up on our speakers list is Mathieu.
Yes.
And he's going to talk about kAFL.
Moment. Okay, right. So thank you for attending this presentation. My name is Mathieu Tarral. I'm working at the SPM team with Lynn. And thank you, Lynn, for the HBFA updates. I'm responsible for kAFL, which is another fuzzer that we maintain, that we provide both internally and externally for all the teams that want to fuzz their software, and we want to help them draft their fuzzing initiatives. Today in this talk, I'd like to talk about the work we did for the past 6 months to increase the adoption of that fuzzer, remove user friction, and build CI/CD integration by building a GitHub action. So the agenda, really quick. First, we're gonna have a quick kAFL overview, how it works, what it is. Then we discuss about what the tooling we've put in place to remove user friction, to remove the barrier for adoption, and the GitHub action that we've built to put kAFL into GitHub action pipelines, and then how to leverage that action to build, for example, a regression test suite. But first, what is kAFL, how it works? kAFL can be described in one line as a hardware-assisted feedback fuzzer for x86 VMs. So really, it's based on a custom QEMU KVM virtualization stack, modified to integrate a custom Intel PT driver, so processor trace, to get the feedback, fast feedback, a custom hypercall interface based on VM call, and as well built into QEMU a super fast snapshot restore system. So we can reach a speed of around 4K execution per second per vCPU. And that's thanks to Intel PML, which is the page modification logging feature that allows us to have some dirty page tracking to quickly restore the snapshot easily. And on the target VM side, we have an agent running inside the VM, which is just a fuzzing harness implementation, talking with hypercalls to KVM. So anyone who is already familiar with QEMU and anything that you can already virtualize in QEMU can be fuzzed with kAFL quite easily. So it's easy to fuzz firmwares, kernels, or operating systems. So some success stories we already have. We have been able to fuzz EDK2 OVMF, EFI apps, and all the libraries that they burn upon. Also, kAFL is the main fuzzer behind the coefficient computing Gus kernel initiative that we have with the CCC repo. And also, we also have another initiative where we fuzz TDVF, which is a flavor of EDK2 to boot TDGuest. Apart from that, we have been able to fuzz Mozilla Firefox IPCs, network apps, Windows drivers, even hypervisors, and SMM handlers. I mean, so kAFL is really a versatile tool that you can adapt to many situations, and yeah, easy to customize. So I need to mention 2 extensions that are quite important here, RedQueen and Grimoire. So usually your fuzzing heuristics will be stuck on complex input passes. Think about a checksum in the code a nested checksum. Here on the right, you can see an example with magic bytes that you have to go through. Well, RedQueen will use VM introspection to extract those inputs and solve them at runtime to explore more code paths. And Grimoire, on the other hand, will analyze inputs to learn grammatic constructs and perform large-scale transformations. So all of this will enable us to not be limited to surface bugs, but really explore a maximum of the program code path. Now, a note on the kAFL agents. I mentioned a few slides earlier that kAFL was using hypercalls. This is a quick overview of the API that we use to communicate. So we include that Nix API.h header into the target and start a series of hypercalls starting by a handshake, then an optional checks and filtering, for example, on CR3, on an IP range, configuring the agent, sending the panic handlers for crash or for address sanitizers. Then allocating the payload, mapping the payload between QEMU and the fuzzer with DMA. And then issuing hypercall kAFL next payload. That will be the payload where the hypercall where the payload will be written into the buffer. And on the first hypercall, the fuzzer will take a snapshot of the VM, and that will be used to restore the VM, and the VM will be restored on that specific hypercall call. So you don't need to build a loop on your harness. This is already taken care of, sort of. And then just start the coverage feedback collection and call the target function that we want to fuzz with the payload buffer. So the agent really is a fuzzing harness implementation, and it can be a function, an EFI app, anything that gets an input buffer. A quick note surrounding debug analysis. kAFL uses the built-in QEMU debugger for its debug sessions. And on the coverage, we leverage JIDRA to map the source code or view enriched blocks. We have scripts around JIDRA to help debugging the target. Now, to better understand what's the difference between HBFA and kAFL. So as you've seen before, HBFA is really its code rehosting as a technique, while kAFL leverages full virtualization. So it's really different. And the speed is also different. kAFL can reach around 4K per second per vCPU, while HBFA can reach much higher execution speed. But on the other side, it's the mocked environment. While on kAFL, you are much closer to the real execution environment, minus the QEMU emulation changes. So you can exercise code paths that HBFA would not be able to do. Regarding the setup, kAFL has a more complex setup because we modified the entire virtualization stack, and we need a new kernel, as well as an Intel PT compatible CPU. So that's more requirements on the side of kAFL. And regarding the tooling, the sanitizers need to be available. That depends on the target, and the debugging, as I said before, is done by the QEMU JDB server. So they really complement each other. That's what's for the kAFL overview. So I've just seen it's quite a complicated setup, and we have been putting a lot of effort to reduce the barrier for adoption to set up a kAFL either on a local machine or on a distant server, and as well as integrated into GitHub action pipelines. First thing we did was to set up an Ansible playbook. Of course, that will allow us to adopt modern infrastructures tools and simplify the setup, split it into manageable roles that you could customize for your own needs, and also distribute an intellabs.kfl collection, Ansible collection, where all the roles are there, and that you can integrate into larger playbooks for different targets that you want to have and customize, and also managing kAFL servers. Reinstalling a server, a kernel is easier that way. Second thing we did was to set up Docker containers. So put the whole user space components, the modified QEMU, libxdc, redamsa, all of this, and the fuzzer, the Python fuzzer, inside a package Docker image that's pushed to Docker Hub, which is it's much more convenient to Docker pull that image. So the kAFL command line is the entry point, Fuzz, conf, debug, subcommands, and it requires a kAFL kernel to run. And when you run a kAFL, you will have that notion of work here, which is simply the output of kAFL, of the kAFL campaign inside a directory. So you can download that directory later on from the CI/CD on your local machine, pull the Docker image, and inspect that by mounting that directory as a volume into the container. And the third thing we did was to develop a kAFL action. So that allows us to run kAFL in GitHub Actions inside a workflow, so that remove the need to setting it up locally. It's really a basic block for kAFL automation, so you can build your workflows around it. Either it's an automated run on each PR, each push action, or manual workflow with the workflow dispatch, or periodically scheduled. It's really a basic block. So it wraps the kAFL command line and it pulls the Docker image, and it needs a self-hosted runner because we need a kAFL compatible kernel. So on the right, you can see that we want to fuzz EDK2, for example, then gather the coverage and upload the campaign results with upload artifacts. Regarding the self-hosted runner, we wanted also to make it as easy as possible to manage it and to install the kAFL kernel. So we reused the Playbook to simply deploy the kernel with one simple command. And that command will download the Debian file, install it, update the grub entries, and reboot the server on the right kernel. So all you have to do is to set up the GitHub action runner. So it's easier to manage one server or fleet of runners that way. And now that section, how we can leverage that GitHub action, that basic block that we did to build a regression test suite and build a workflow around that. So really quickly, first phase, you will just run a kAFL campaign. So build a fuzzing harness in OVMF. Run that campaign for 1 week, for example, collect the crashes and then the panics inside the corpus, triage, remove the duplicates, and then git add the relevant inputs into the EDK2 repo, for example. And in a second step, you will use the kAFL action to schedule regression tests. So here on the right, so I'm assuming that we have a specific branch that we rebase on every pull request, for example, and that we fuzz an OVMF built with a harness inside. And I'm using the seed dir parameter to provide all the seeds that we have collected previously, which are really test cases. And all those seeds are going to be executed once, and then the remaining time we will spend randomizing inputs. So that's the basic that allow you to build a regression test suite that actually exercises more code path because it randomizes the inputs once it's done with the normal inputs. So regarding the scheduling, you'll be able to do that on each pull request, for example, and run for 10 minutes, or schedule that on a weekly basis with the scheduler built in GitHub Action. Every week, for example, you would run that regression test suite and then automatically send an email if you have a test case that doesn't pass anymore. Regarding future ideas and discussion, what we want to do is to develop pipelines around that kAFL action that we've seen, to really measure that action and see what workflow we could build around that. Find ways to partially automate the bug triage. How can we automatically open an issue with at the end of the Fuzzing campaign and reduce the burden of looking and of inspecting the results. Another direction that we are taking is also looking at using the upstream kernel. So we want to be able to run kAFL from a Docker container without the need of installing a kAFL kernel, a specific kAFL kernel. So we want to upstream maximum of our patches and adopt upstream mechanisms that are already there. And finally, adopt libfl as the main fuzzer front end that will allow us to use the latest techniques in libfl. So thank you for the time. This was just a little tour of kAFL and our effort at SPM in the past 6 months to help our team fuzz their software and what we've developed around that. We'd like your ideas, your feedback, and your workflows. And we want to, of course, make sure that GitHub action and integrate into your main CI/CD pipelines. So don't hesitate to reach out to us. You can see the links on the right of the screen. There is a Discord and my email here, mathieu.tarral@intel.com. Thank you very much. Thank you, Lynn, Eric, Brian, Lelia, and Mickey.
Thanks, Mathieu. I'll start off the questions, and that is running this through Git, or I mean through CI/CD. How do you limit the amount of time that the fuzzers run? Because obviously Git runners have a time limit on them. And so how do you know how long to let it run? How do you let the fuzzer know?
You're on mute, Mathieu.
Sorry, right. So there is a parameter in the action to limit the execution to a certain amount of time. That was your question. How do you specify the time limit of the fuzzing campaign?
Yeah.
So I think it's in one of the slides. Yeah, you have here timeout 600, which is 10 minutes.
5 minutes.
Yeah.
Okay, thanks.
So yeah, it's solvable for self-hosted, and then in terms of HBFA, one of the other options is we're working towards OSS Fuzz and cluster Fuzz type setup, and that may be able to step around that whole issue as well.
Okay, yeah, because I know that we were concerned about that. You know, having a CI/CD workflow that already takes a couple of hours. How do you know when to stop a fuzzer from fuzzing? And so when you do have test cases that fail, can you actually create and save that as part of the initial corpus?
Yeah, you would be able to upload the test cases as upload the entire artifact, the entire rock there, and then examine that later on and add those test cases in the corpus.
Okay, and so you would actually check those into the Git repository, correct?
Yes.
Okay. Does anybody else have any questions? Amazing. Thank you, Lynn. Thank you, Mathieu, for coming and telling us about fuzzers for CI/CD and Tianocore.
Thank you, everybody.
Okay.
Thank you.
Now I want to bring JP up, who is going to present about Python UEFI and the changes that have been going in upstream for that.
Thank you, Mickey. I'm sharing my screen. Let me know if you can see it. Hope it is visible.
We can see it. Yeah.
Okay. Hello, good morning, good evening, everyone. I'm Jayaprakash Nevara, working as System Software Architect at Intel. So I'm going to talk about bringing the power of Python to UEFI shell. I'll be talking about this topic. Acknowledgements to Kine Michael has been helping me, giving certain directions, inputs in making this particular project possible. So I would like to start with the platform validation debug landscape, typically how it looks like in any organization when it comes to the system design and all. So platform and firmware validation debug is very critical for establishing the quality of the platform so that we can achieve the time to market targets both for customers as well as for us. Typically, the validation debug landscape involves methodologies which are OS based as well as UEFI based. It's a combination of OS and UEFI based methodologies which are used for most of these use cases like platform, firmware validation, debug, automation use cases. So let's see like what kind of challenges we see in the OS based methodologies and UEFI based methodologies. So with respect to OS based methodologies, we have like when it comes to security validation, it's becoming increasingly difficult with the addition of new security features by the OS, Microsoft Windows OS. As and when they add some new features, it's making difficult to read certain registers which are required for validation of the security features from the OS. So also the BIOS validation, right? Certain BIOS settings are not exposed to the OS runtime, making it difficult to validate flows related to those BIOS settings. Example, secure boot is one example, but there are, I think, a couple of other things also. So what it makes, it actually leads to adding the dependency on OS for firmware validation. So the performance will become a critical issue in the pre-silicon environment. Typically in the earlier stages of pre-silicon environments, booting to an OS will take much longer time, so leading to overall validation cycle. It increases the overall validation cycle time. And also OS may not be stable. It leads to delays in the milestones, right? Because of the dependency on the OS. Besides that, some of the certain power management flows are difficult to validate from OS. For example, cold boot, which is very easy to do it from UEFI shell using just there is a command called reset-c. With that, we can easily validate the cold boot flows. So these are some of the challenges. I have not listed all the challenges. These are some challenges which I have come across. I have heard from people, experts who are doing the OS-based validation. So now let's move on to the UEFI-based methodologies and the challenges that we see when validation debug is done from a UEFI shell itself. So typically it requires uses of special purpose UEFI applications, leads to less or no reuse of the code across OS and UEFI. So we have to develop these applications in addition to the applications that are being developed for OS based validation debug use cases. So it's basically a duplication of effort, leading to greater development cycle, increased cost, effort, right? Also, it requires knowledge of UEFI for anyone to develop UEFI applications, which is considered as a niche skill set. Typically, the validation debug engineers, a lot of them are not familiar with writing UEFI applications today. So it's a very small developer community. I mean, we do not have like a large developer community like Python and other things, right? So getting help also is very much restricted here. And for automation purpose, the shell scripting what we have on EFI, which is typically the NSS scripting, is very basic and naive. It cannot be used for advanced automation purposes and all. So most of the UEFI, because of that, like most of the UEFI based validation or debug will be either manual or semi-automated in nature. Okay, so these are some of the challenges. So how do we address, like what we can do to address some of these challenges, what we see both from the OS based methodologies as well as from UEFI based methodologies, correct? So we know that like Python is one of the most widely used programming languages today for a lot of validation automation purposes. Can we like bring Python to UEFI to address some of the challenges that we see? Can Python help like unify the strategy that can be used for validation debug use cases across OS and UEFI shell? Right. So this is what we wanted to address. And so the reason like why Python we choose, right? It's one of the most popular and it's a very high level programming language. It comes with a lot of power of expression, like with less code we can achieve more. It's an open source and OS agnostic language also. And it's highly portable. It has been ported to several machine architectures, operating systems, and typically it is considered as a more productive language because the productivity of the developers is much higher here because we are going to write less code, so there will be less bugs introduced, less debug effort required, less validation effort required because we are going to write less code here. And it has faster development life cycle, and it also supports like various methodologies like object oriented, procedure oriented, functional, right? And it comes with extensive library support, standard library, and it's one of the most easiest programming languages to learn. And today, a lot of OS based validation debug is actually kind of aligned towards using Python. So if we bring Python to UEFI shell, then we can have an unified strategy, and we will be able to reuse a lot of the tools, code, right, across OS and UEFI shell. So some of the key milestones in this process, right, like when it all started, like when we started exploring about like bringing Python to UEFI, porting Python to UEFI shell. And so it all started in 2018, like trying to explore if is it possible to run Python in UEFI shell. So then I came across a version of Python 2.7, which was already ported to UEFI shell, thanks to the person who worked on it. And I explored, I mean, I built it, understood how it works, what has been done to make it like work on UEFI shell. So with that knowledge, like I took somewhere in 2020 Q1 the Python 3.x version. At that time 3.6 was the latest one. So I took 3.6.8 and then started porting it to UEFI shell and was able to get the first version of the Python port to run on 3.x run on UEFI shell. And then worked with the chipsec team, which is chipsec is a security validation tool, which is an open source tool today. So worked with them and they adapted Python 3 port and kind of like they streamlined their entire tool to use 3.x version. So they were initially supporting like 3.x for OS and 2.x for EFI shell. So with Python 3.x being available on EFI, they were able to take away their effort that they were putting in maintaining 2.7 and all. And then along with that, like open source this 3.x version to the Tianocore EDK2 project somewhere in Q3 2021. And then after that, like added support for GCC compilation. Initially, we had only MSFT Visual Studio toolchain support, and then we added GCC compilation support also. And then, I mean, internally, like at Intel, we also worked with the PCI IP enablement team in BIOS and developed an utility to improve the quality of the PCI IP firmware. It happened sometime in 2022 Q2. And there are like a host of other things that for which Python is being used today at Intel. So, so why open sourced this Python 3.x, correct? So Python is a huge code base with over 1 million lines of code. And Python UEFI is actually not a funded project here. So, and Intel customers were actually looking for Py3 support on UEFI shell. And Python 2 UEFI port in EDK2 is like very old and it's became absolute because of the end of life declaration starting from January 1st, 2020 for Python 2.x branch. Also, besides that, like wanted to take advantage of the community contributions to improve the quality of the quality and the capabilities of the Python on UEFI, and to build an ecosystem of Python-based open source tools for UEFI shell-based uses. So chipsec is one best example, like which is an open source tool and helping the security validation domain. But I think we can do even more. We can build more tools to do a lot of other, mostly validation, debug, those kind of activities only. So it will be a win-win situation for both as well as customers. So what capabilities we have today? Like currently we have enabled basic Python scripts running support on UEFI shell. We can also run any UEFI applications, commands in an automated way from Python script, so that we don't have to throw away the existing UEFI apps which are already there, well tested, right? We can reuse them and use them from the Python scripts. And also a set of standard Python modules are enabled on UEFI. So details are available in the next slide, which I'll be flashing in a moment. And there is a module called EDK2 module. This is the core of the Python UEFI port, which provides all platform register read-write capabilities, including MMIO, MSR, IO port, PCI config, CPU ID, a lot of other registers, using which we can build any tools for validation, debug, automation, those kind of activities. So these are, continuing on the capabilities. These are the modules currently enabled from the standard library, which comes along with the Python installer package in OS world, right? We took like a subset of them and enabled them to run on EFI shell. I mean, some of these things are required for writing basic applications and all. But yeah, I mean, we have not enabled every standard library that comes along with the Python interpreter. But yeah, on a case-by-case basis, we are enabling them. Python UEFI interpreter uses, like currently who are all using Python UEFI, right? ChipSec is one open source security validation tool, which is actively using the Python UEFI port. And they transitioned recently, as I mentioned, to Python 3.x, and the EOL, the Python 2 support completely from ChipSec tool code base. Besides that, a lot of automation tests related to BIOS settings, security settings are being done. I mean, at Intel, I can say because like I have access to, done by multiple automation and validation teams here. And also, I have created an statistics for EDK to libc usage statistics. Here, I'll quickly flash it. So it has details about like how many users are using at least some clones, number of views, those kind of things. It will not give us the exact like usage details, but at least it will give us some statistics about the uses of Python UEFI interpreter. So this is the most recent one. It has like starting from March 17th till May 3, we have like nearly 675 unique visitors, and total visitors are 3,269 for the Python UEFI project. And there are like 600 clones starting from March. These statistics are only available from March 17, 2023, even though the Python 3 port was available in 2022 itself. So it took some time for us to like set this up, getting the user statistics and all. And then this will kind of like give us a rough estimation about like how many people are using it today. But it will not help us get to know like for what all purpose they are using. I think that's a little bit challenging. And some of the support that we are seeing from the community, right, for promoting Python UEFI work, just put it for reference here. There is one person who actually created a fork from the Python UEFI EDK2 libc repo, and then added support for EFI Py module. So EFI Py module is another very useful module which provides low-level protocol access, like the EDK2 protocols, what UEFI shell protocols, right? So those things can be accessed from Python scripts. So that support is available through the EFI Py module. I mean, people are actually adding new features into it in their own forks, but for some reason they're not contributing it back to the EDK2 libc. I think there are certain licensing restrictions because of that. I think EFI Py is a GPL2 license, and that's why I think they have not contributed it back to the EDK2 libc main repo. And this is another blog in I think China or Taiwan. They are promoting the Python 3.x port to make it more, I mean, reachable to the wider audience and all. So this is a blog that has been written in Mandarin. I came across and then just captured it for reference. And similarly, like we have added the details of the Python UEFI port availability into the python.org official website. We worked with closely with the Python core developer community and got this information updated into their website also, so that more people can see, learn about Python UEFI support, and then possibly like contribute to the future features as well. With that idea, like this information has been captured in the official website of the python.org. And then the future work. So basically, like why I came here, I just wanted to reach out to the larger community of the EDK2 Tianocore, and then like kind of create more awareness about this project, to get active support from the community for enhancing the capabilities and the features of Python UEFI. So basically, to port newer versions of Python UEFI, what we have is currently 3.6, but Python has already moved to 3.11. So it needs some effort to port Python 3.11 to the EFI shell. So looking for some support and contributions in case if any volunteers want to do that. And then add support for building interpreter with additional compiler tools like GCC is already done. Clang and other tools is something that we are looking for, and add support for other processor architectures. Currently, Python EFI is supported only for x86, and since EDK to Tianocore project is used for other architectures also, like RISC v5, ARM64, ARCv6. So looking for like adding support for these architectures also. And also upstreaming of Python UEFI changes to python.org repo, so that like we get for free, right? The Python support for UEFI we get for free. I mean, community will take care. I'm not sure how easy or how difficult it is, but this is one of the items that are in our list actually. And then there are other modules like C types is a very important module for interfacing any C code to the Python layer. We have a build support for that with Microsoft Visual Studio Compiler, but with GCC we haven't enabled it. So we're looking for someone who has expertise with the GCC compiler to help us. And then LZAM compression module support. I think this is requested by chipsec tool. This is something currently we haven't enabled in Python UEFI. So we want to enable it. And socket module support for remote use cases. And also work with the EFI Pi module owner to get it open source through EDK2 libc project. Currently, the EFI Pi is a closed source kind of project with GPL license. Maybe I think we reached out to the owner, but somehow is not very much inclined towards making it an open source one. We'll have to see how to influence the owner of the EFI Pi module to make it open source, so that the features of EFI Pi, right, can be used for even unit level testing of the firmware from EFI shell. We don't have to write an EFI application to exercise EDK2 UEFI protocols. We can write all of that with the Python script. It's a very good module actually. So yeah, these are some of the future works that are in pipeline, and yeah, wanted to like reach out to the community and seek their help, guidance in getting these features implemented. So these are some of the outstanding Bugzilla tickets which have been created to map to some of those future work, right, which I just listed. So the Bugzilla query is also listed over here, just in case if you want to take a look at it. And then these are some of the references. The Tianocore open source project is available in the EDK2 libc repo at this location for the Python 3.6.8. And then the chipsec open source project is available over here. So any questions?
Thank you so much for doing this, JP. Great information on the work that's been being done with Python and UEFI.
Thank you, Mickey. Yeah, definitely. I need community support in some of those features, right? I'm not an expert in everything, so it would be good if someone from the community can contribute to this project as well.
Okay. Well, thank you, everybody. I want to thank you all for coming. Sorry we ran a little bit over today. I'm going to stop the recording.